Welcome to our NPTEL lectures on the power quality improvement technique. This will be our second lectures on the hybrid uh, active filter. So, we were discussing about some combinations of this active and the passive filter. So, this is also a possible solution to have all series combination in between these passive combinations. Generally, it will mitigate maybe fifth harmonic voltage and also some portion of it, and this will mitigate the seventh harmonic voltage. This way it has been met. So, it is called the hybrid filter as combination of the series connected passive filters with active series in parallel with passive series filter. So, this is also a combination. Generally it has been preferred where source impedances are high. Similarly, you can have another combination. These are the two shunt filter, one is active, another is passive, and with that you have another series filter. So, this is a hybrid filter, is a combinations of the passive filter, two passive filters, and these are the active and the passive shunt with the series passive. This has been done where we do not have much problem on the source inductance. And now we can have a T network. T network gives good amount of attenuation, as you know. This is a pi network. So, here passive, first passive, so it will sink the more, take out the more buck of the harmonic contamination. Then what happens, this will block the fifth and seventh voltages mainly, and thereafter what happens, this will mitigate the remaining part of the harmonic based on the mitigation, because it may detune due to the fluctuations of the voltages, and thus you may not get the desired TSD, and ultimately this will have a final cleanup operation. The hybrid filter is a combination of the passive shunt, passive series and active shunt filters. And same way you can have the cleaning up operation in the series part. Mostly it will clean up the voltage, and thereafter you whatever remaining, this will be sink into the shunt component. The hybrid filter as a combination of the series connected passive series with the active series and the passive shunt filter. Hybrid filter as a combination of the passive shunt, active series and the passive shunt filter, this has been shown. And similarly, you can have the ZS, and you can have this device as a series shunt, series, and thereafter you have a combination of the active and the passive filters. The hybrid filter is a combination of the passive series and series connected passive shunt with active shunt filter. A hybrid filter is a combination of the passive shunt and series connected active shunt with passive shunt filters. So, you have this passive shunt, then again you have active passive shunt, and this will mainly a shunt active filter solution where dominant harmonic will be mitigated by the passive, but it may detune, and for this reason this cleanup operation is being done with the combinations of the active passive. I have shown you, please recall a shunt active power filter of this combination, where it can also reduce the rating of the devices apart from the compensations of the voltages. And similarly, you can have a shunt combination. Generally it is not been preferred, because mostly this mitigation has been done by this, and thereafter you have a series shunt, series active filter, then the series passive filter, then the shunt passive filter. So, the hybrid filter is a combinations of the shunt active first from the, if you are looking from the source side, and the passive series and the passive shunt filter. A hybrid filter is a combinations of parallel connected active series AFSS with passive series and passive shunt. Okay. There are, you see there here, this is the source, harmonic source, because of that the source inductance. Then this will mitigate the harmonic voltages, and this is also will mitigate the harmonic voltages, and whatever the harmonic current will be there, since that harmonic voltage is less, this will be sink into it. And this is the combinations where this is double tuned, as you have seen in case of the passive filter. With that you can have a active shunt filter. Mostly this solution is there when there is a lower source inductance, and thus you do not have a greater value of the voltage, because you know, if there is a fifth harmonic voltage, even if you connect a resistive load, this will flow. So, this fifth harmonic voltage arises due to the fifth harmonic current when it passes through the source harmonic, source inductance. And for this reason, this topology has some merits and has gaining the attention to the researcher. The hybrid filter as a combinations of the passive shunt and parallel connected passive shunt with active shunt filters. Now, you have this passive filter, thereafter this is series connected, parallel you have a both active and passive, and so it is essentially an UPQC. But I was always saying that you should have a right shunt combination. You see that this is a left shunt combinations. In UPQC I have said we generally prefer right shunt, but this is a left shunt combination. With that, you know, to reduce the rating of this series filter, series active filter, you have put a passive filter, and that will mitigate the value. Similarly, you can have, this is essentially an UPQC, and so this will be a normal UPQC. This is a normal UPQC with right shunt combination, and then also you left something to be compensated by your series filter. So, this is said to be the hybrid filter as a combinations of the active series and active shunt and the passive series filter. So, I was telling then that where you use the left shunt, there is something you try to use the left shunt. Essentially, it will provide the sinkage for the harmonic, then you block it, and thus the rating of this fifth and seventh harmonic compensation required to be less, and similarly rest you block it here. Here you mitigate the fifth and seventh harmonic and you compensate it, and whatever you are been tracked out, that has to be lastly mitigated by this passive series filter. And to reduce the rating of it, since this device sees the whole rating, so we try to reduce the rating of it by this kind of combination. So, you have series combinations. So, this will see the whole rating. The parallel to it, you will have this combination, this voltage will be the same. So, it will be equivalent to the fifth harmonic voltage or seventh harmonic voltage where it has been tuned, and thus you have a compensations on the rating. This hybrid filter is a combinations of the active series and parallelly connected passive series with the active series filter. Similarly, this part is a UPQC essentially with a left shunt combination, and with that you have a passive series filter to reduce the rating of the active series filter. So, this combination is also, we will call it is hybrid filter. Similarly, you can have two active series filters, and this can be a passive filter, and then you can have a two passive filter. You can have, sorry, pardon me, you can have a two shunt filter. One is active, another is passive, and another is the series active filter. So, this is also a combination. Now, you have series passive, you have series active and passive. This combination is also very useful combination. This one first mitigate the voltage harmonic arises mainly from this fifth and seventh, and ultimately this one will compensate the rest of the harmonic, thus overall rating gets reduced, and shunt part will compensate the current part of it. Similarly, you can have this combination, and thus the rating of this shunt active power filter of the DC link voltage will be reduced, as we have seen discussed in case of the shunt active power filter, this kind of topology, and that can be an extension also in UPQC. So, essentially it is an UPQC with the left shunt combinations, with that hybrid part, shunt is hybrid and the series part is as it is left out. In this case, it is also an UPQC where the series part is hybrid and shunt part is left as it is. And this is also a combinations possible where you have a two series active and one series passive. This can be connected back to back, and this task is to mainly to compensate the major harmonics, and whatever the remaining harmonic may be compensated by this one, so that overall rating becomes reduced. Ultimately, please understand that you have to use an inverter. So, inverter of course will be beneficial if rating is low, though you require the two inverters. If the rating is not so high, so it does not matter, you can have those inverter placed. And similarly, this one is a active series and the active shunt, and thereafter you have this shunt. So, essentially it is a right shunt UPQC with extra shunt passive filter. Similarly, you can have a left shunt UPQC with a passive filter, generally it is been preferred now. I was telling you the task of this entity to clean up so that UPQC can act better. So, you can have this notion, again this can be interchanged, first passive then active, and thereafter we can have a hybrid filter with the combinations of the active series, passive series filters and the active shunt filter. So, first you have a series filter, this will mitigate the all the voltage harmonics coming out from this due to the source inductance. Then you have a passive filter, thereafter it will be mitigated by the current, part of it will be mitigated by it. So, again this combination, you see that there is a two shunt filter and another is a series filter. Series filter essentially block this voltages fifth and seventh. So, this will supply the other harmonics, fifth may be supplied by it, seventh may be supplied by it. So, the overall rating get reduced, and this is also the combination it is a combination where you got a shunt path is here and this combinations of the passive filters and active filters. and series part is left as it is. Similarly, this combination is there is a 2 shunt, mainly it is to reduce the effect of the harmonic current harmonics. So, here you have a shunt active filter, this is a shunt hybrid filter, and both are been placed. So, that this is maybe the compensating the higher order harmonics, and this is for compensating for the lower order harmonics. Same way you can have, this was I was telling that you can have the shunt, passive shunt first, then active shunt, in between you have the series. Essentially this part is a right shunt UPQC. This hybrid combination of the passive shunt filter, active series filter and the active shunt filter. This combination is quite popular, because what essentially you see when you see that this combination, it is essentially an UPQC. So, with that you add on something and thus you get a better compensation. Similarly, you can have these combinations. Essentially these all entities are UPQC. With UPQC, to reduce the series rating, we will go for this solution, and that is hybrid filter as a combination of the parallelly connected passive filters with active series and active shunt filter. And thereafter it is this one, and you have shunt, active shunt 1, then this is passive, and thereafter it is a double tuned filter, and mostly it is active, and this one is passive. So, essentially it is a shunt active power, hybrid shunt active power solution with passive entity being placed in parallel to the another passive entity. This hybrid filter is a combination of the shunt active power filter SH1 in series with the parallelly connected active shunt filter SH2 and the passive shunt, this filter PSH. So, now as you understand, this combination is a active combination is nothing but your UPQC. Though you can say that it is active combinations, and it is the normal UPQC, and this is essentially the right shunt solution, and we prefer the right shunt solution because first you mitigate the voltage harmonic, then you compensate the current harmonic. Here it is called the left shunt solution, but generally we do not prefer, because we cannot clean the voltage at the PCC, because since voltage is dirty, then reference generation also becomes challenging. And for this reason, this method is been preferred. But once you have this combination, here it has been preferred. So, this is one of the preferred condition. So, this one and the previous one, what is seen, the add on is a passive element, and it may be existing previously, and thereafter you add a UPQC, and thus the overall topology comes like this, and that may be the condition sometime. It is a retrofitting, you are using the first you had this is a history of conversion. First it may be that capacitor only been placed to mitigate the power factor problem. Once you see the power factor problem, and if you have adjustable speed drive, it causes a problem. So, you cannot leave this capacitor alone, and for this reason you put an inductor. So, that inductor essentially becomes got a selectivity, this LC combinations, a single tune filter. Once you get a single tune filter, you find that it is not enough to compensate because of the detuning problem, and it is the aging of the problem, and thus you place a UPQC. So, ultimately it becomes a left passive shunt UPQC. So, this is the one of the solution. Now we talk in more detail, since this is a combination of the two series filter before cleaning and after cleaning of the current. So, this will try to clean the PCC voltage and then only inject, and ultimately the load side is quite high. In between, due to the source inductance, some amount of the voltage also comes into the picture, because, and so in between you again you place a series active filter to mitigate those harmonics. So, it is called the hybrid filter as a combinations of the active series AF-S1, active shunt AF-SH, and active series AF-SS2 filters. The hybrid filter as a combinations of the shunt filter and the active series filters and the active shunt filter, that also comes into the picture here. So, this is also there. You have a two passive filter. We have Professor Bhattacharya act on it, but this was missing. So, you got a since this voltage is maybe an add-on. So, your PCC voltage may be less due to the sag. So, you do not have a problem, but here your PCC voltage may be high, but your voltage has been clean, and thus you get you give a total solution, and ultimately you have segregated the problem. Maybe the dominant harmonic, it will produce FSH1, and FSH2 may produce the other higher order harmonics, and you get a total optimal compensation. Look, total optimal compensation depends on the many issues and the many areas, and also sometimes it is the historical reason also. What kind of solution already it is existed there, and if it is a totally a new site, it is greenfield kind of entity, that is okay. But most of the cases we require to retrofit it. Once you retrofit it, then of course you have to take into the consideration of the previous solution, and you have to accommodate it, and thus you give a better solution. And that is something, the main intention to understand the hybrid power topology. Of course, you do not go by the this kind of topology at one go. If UPQC is sufficient, why you go for it? See, you already find that there is a passive filter, then you connect a UPQC, then sometime this topological variance comes into the picture, and that required to be analyzed, and you have to give optimal solution. So, for this reason we prefer these entities. Now, this is one of the example of it. You have seen the one leg block diagram. This is one of the shunt active power filter. What is it? You know, you have to match the circuit. So, here this is the circuit, not this. So, you have a active and the passive combination. So, you generally what happened, you have active power filter. It was a history, and at that time it was a square wave kind of generation of the STATCOM with a GTO or thyristor, and you step it up because this rating required to be less because of the switching problem. Switch at that level was not available. So, we wanted to find solution is a 2-level inverter, and now you tune to the passive filter into the 5th, 7th and the high pass filter, and ultimately this part is a passive and this part is active, and little detune will be automatically adjusting this active power filter, and thus you get a better solution. So, what we can say that active hybrid shunt active filters are based on the combinations of the active filter, 3-phase transformer, passive filter consisting of two single tuned filters of the fifth and the seventh harmonic, these are the dominating harmonics, and a second order high pass filter tuned to the 11th harmonic frequency. So, this is a practical solution what we have discussed till now with this one line diagram. So, what we can say that although these hybrid filters are slightly different and we have to understand the complexity of it, different circuit in configuration, they are almost the same operation principles as the passive filtering operation. Just combinations with the passive filter makes it possible to significantly reduce the rating of the active filter, that is also a challenge sometimes. The task of the active filter is not to compensate for the harmonic current produced by the nonlinear load, but also provide or achieve the harmonic isolation between the supply and the load, and as a result no harmonic resonance occurs, no harmonic source current flows to the supply, and thus it tamps out the harmonic oscillations. Thank you for your attention. We shall take out how does it do it by this active filter in our next class, and thereafter we will have a conclusion in class. We will conclude what we have studied in the shunt active power filter, series active power filter, UPQC, and most of the solution you see that is in a harmonic domain, and we shall discuss about also the Notch spike and those solution, and we will conclude our discussion. Thank you.